Hey Robert, great to have you on the show today. We're diving into clean code principles. This piece of Java code seems well structured, but it's lengthy. What are your initial thoughts?
Yeah, Andrew, it's definitely thorough. The args class uses an argument marshaller interface, which is a neat way to abstract different argument types. This is good design, promotes code reuse.
Right, modularity. But it looks like a lot of code for such a simple task. Is it worth it?
Well, there's a trade-off. The Java approach emphasizes robustness and clarity. You get really detailed error messages, which helps a lot in debugging.
So robustness is the price of the verbosity?
Exactly. Look at how the argument marshaller is implemented. Each type, like Boolean, string, integer, has its own class. If you need a custom type, you simply add a new implementation.
That's very maintainable. But isn't that approach repetitive? There's repetition in the code, with the get methods, for example.
You are right. It could be more concise. Java, being statically typed, requires more boilerplate to define the return types and handle errors, but it makes the code more dependable and easy to work on later.
Imagine a situation where you want to add a date type. How would you extend the class?
A new argument marshaller implementation, a new get method, and an update to the parse schema element function, the new args exception error code and appropriate error message. A trivial addition to the design.
Very neat. What about comparing it to a Ruby implementation? You mentioned it was much smaller, right?
Yes, there is a good reason for that. Ruby's dynamic typing is more concise, which can lead to faster development.
So, Java's strength in this case is maintainability and extensibility, and Ruby's strength is faster prototyping?
Precisely. It boils down to the specific needs of your project and trade-offs you're willing to accept.
So, is there a one-size-fits-all approach to clean code?
No, Andrew, there's no universal answer. Clean code is about choosing the design that best fits the context, considering factors like the project size, the team's expertise, and anticipated future changes. This Java implementation shines in a larger code base.
Makes sense. Thanks, Robert, for the clear explanation.
You're welcome, Andrew.
Okay, Robert, we've seen how quickly this code is spiraling out of control. It's like a runaway train. Why did it get so messy so fast?
Well, Andrew, it's a classic problem. We're adding functionality incrementally, but we're not thinking about the overall architecture and how this will change over time. The structure hasn't evolved alongside the growing complexity. It's the difference between adding a room to a house without considering the layout or making big, confusing changes to the plumbing after the fact.
So, what's the solution here? Just stop adding features and start rewriting everything?
Chuckles, no, not exactly. We don't want to throw away good work. Refactoring is the key here. It's about restructuring the existing code to improve its design and maintainability without changing the overall functionality. It's like reorganizing a messy office to make it more efficient.
I see. So, refactoring is like a corrective maintenance procedure for code?
Exactly. It's proactive design. You start to see the patterns emerging. And you see that, in the example here, each new argument type, Boolean, string, integer, is requiring similar changes in many parts of the code. This is begging for a class, the argument marshaller. It separates the parsing logic for each argument type.
That makes sense. So, the argument marshaller class handles the different argument types? Like a specialized parser for each?
Exactly. It encapsulates the parsing and setting logic for a given type, making the main class, args, cleaner and much more manageable. You can add new argument types without affecting the core logic. It improves modularity and reduces coupling. It's essentially about creating reusable pieces.
Wow, that sounds much more organized. But isn't that a lot of work up front?
Yes, it requires upfront planning, but significantly reduces the long-term maintenance burden. You're spending some time refactoring, but you will avoid far more time-consuming debugging, maintenance, and rewriting in the long run. The effort paid off immediately when you add support for additional types. It keeps the system from becoming a messy, tangled web.
This is very important, Robert. So, what's the impact on the tests?
The tests need to reflect the new structure. If we use mocks or stubs appropriately, the tests can be decoupled from the internal implementation details. The important part is that they validate the interfaces rather than the underlying mechanisms. The new class separation makes writing new tests quite easier.
Thanks for explaining this to me, Robert. That's really helpful.
You're welcome, Andrew. It's about making good choices early. You know, like deciding on the kitchen layout before you buy all the appliances.
Robert, this piece really highlights the importance of incremental changes, right? It's like building with Legos a little piece at a time.
Absolutely, Andrew. That's the beauty of TDD. You're essentially building up trust in your system bit by bit. Every change is validated, and that reduces the risk of introducing major issues down the line.
So, the author in this example, they were making small, testable changes to the argument marshaller class, right? How did the tests actually help pinpoint the problem?
Yes. The tests were crucial. When a tiny change was made to handle Boolean arguments, some of the tests failed. That immediate feedback showed exactly where the problem was. The code wasn't handling null values properly anymore. This is a common mistake.
Wow. So if you introduce a change in the middle of your system, the tests tell you if you've broken something?
Exactly. That's the point. The tests are your safety net. If you can't write tests that cover your code, you're likely missing some critical logic.
You mentioned these unit tests. What's the difference between them and other types of tests?
Well, a unit test tests tiny pieces of the system in isolation. In this case, they'd be testing the getBoolean method in isolation. Acceptance tests, in contrast, test the system as a whole, making sure the overall behavior is intact. Both are vital.
So, what's the lesson here, besides testing? Is there a pattern to how they fix this issue?
It's all about avoiding massive code changes and instead focusing on precise, incremental adjustments. See how they started with a hash map and then, step by step, refined the getBoolean method to handle the null case with the new logic? That's TDD in action. You have to think modularly.
So, is making lots of little changes just a matter of practice?
Practice, but also a mindset. You're not just coding, you're actively building trust in your own work. With every test pass, you gain confidence, and with every failure you learn.
This is super helpful. Thanks, Robert.
Anytime, Andrew. Keep asking questions.
Robert, you've hammered home the point that code needs more than just functionality. So, how do we practically implement continuous code cleanliness? It feels like a tall order.
Precisely. It's not about perfection, but a consistent, proactive approach. Imagine a messy desk. It's hard to work effectively, right? Same with code. Clean up your workspace, module, immediately.
But how? What if the mess has already been piling up for months?
The first step is awareness. It's often hidden dependencies lurking in the shadows that cause problems down the line. You have to look for those relationships that might unexpectedly break. Imagine
a spiderweb of connections?
Exactly. You trace these dependencies to understand how one part of the code affects others.
So, constant scrutiny? It seems like an overhead.
Absolutely. A bit like keeping your car well maintained. Regular servicing prevents major breakdowns and costly repairs.
What about teams under pressure to ship quickly? Doesn't that put a lot of pressure on this process?
Time boxing is key. Build those regular quality checks into your sprints. Small, incremental improvements to code design can reduce unexpected issues further down the road.
But it sounds like cleaning up this mess can be extremely time-consuming.
Absolutely. But that cost is insignificant compared to the long-term maintenance nightmare you create otherwise. It's a mindset shift.
So we're essentially building preventative maintenance into our workflow?
Yeah. Just like preventive maintenance for a car, you don't wait for the engine to seize up before you fix it. Little things done proactively.
You're talking about an evolution of programmer habits, not just tools.
It's a cultural shift. But the payoffs are immense in avoiding the huge headaches later.
Got it. Now I'm envisioning those massive, tangled spaghetti code bases. A real monster to tame.
Indeed. But far more manageable in pieces. Start with one file, one module, one clean dependency, a little bit at a time.